Alright, so this is problem 315 from the textbook. So for just like all these problems, we're going to start out with a free body diagram. And we're going to do it about maybe the point A. And so we'll replace each of these springs with a force. So that's the force of AB. And this is let's see, well, I can do that in a second, but it's basically 3, 4, 5 triangle here. Then we have the force, let's see, undo. Force of AC. And with that, it's this is an equilateral, so 3, 3 are the two lengths there. And then we have the force of AD. And we'll do the X and Y. So this is a coplanar problem. So let's sum the forces. We know the sum of the forces equals mass times acceleration. It's an equilibrium, so that's 0. So the sum of the forces in the X direction equals 0, and the sum of the forces in the Y direction equals 0. So let's do the X direction first. So we basically have negative FAC times, let's see. Alright, so for this triangle, the hypotenuse would be 3 times the square root of 2. So for that equation, so we have negative FAC times 3 over 3 square root of 2. Would be that X component, and that's in the negative direction, plus FAB times 4 over 5, and that equals 0. We know some stuff about what's going on here. So F of AC, we know the K of AC. We don't know that unstretched length. So we'll say it's negative K of AC times that S of AC, 3 over 3 times 1 over square root of 2, plus FAB we actually do know stuff about, so that'd be K, so that's that 30 newtons per meter, times that unstretched length, which is 3 meters. Alright, so sorry, it's not the unstretched length, but so we know the unstretched length is 3 meters, and so we want to know the change in those lengths. So it went from 3 was the initial unstretched length, and 5 is the stretched length. So that's going to be, erase that. So the length minus the original length is what that S is. So let's see. Sorry about that. So what happens when you write the wrong thing down? So unstretched length, or you call something wrong, is L of LAB is 3 meters. So that's equals L original. The L now equals 5 meters, because we know it's a 3, 4, 5 triangle. So that times 4 over 5 equals 0. So now we can do, so K of AC we do know, negative 20 newtons per meter, times that SAC, which is that change in length, times 1 over square root of 2, plus 30 newtons per meter, times the length is 5, minus the original length is 3, that's meters, times 4 over 5, that equals 0. I'm going to Go to the next page. So now we have that see, we have negative 20 over square root of 2 times that SAC. So we don't know the original length, but we know the final length is 3 square roots of 2 meters minus the length original of AC, and that equals negative, I'm going to go ahead and multiply this out, 30 newtons per meter times 2 times 4 divided by 5. So we get negative 48 newtons. The meters cancel out. And let's see, it's square root of 2 over square root of 2. So, oh yeah. So when we multiply through there, be careful. Let's see. So we'll go ahead and multiply through here, and we basically get negative 20 times 3, and the square roots of 2 cancel out for that side, plus 20 over square root of 2 times LAC equals negative 48 newtons. So that means LAC is going to equal negative 48 plus 60. It's also newtons. And then times the square root of 2 over 20. So LAC equals 0.8485 meters. All right. So that was just from the sum of the forces in the x direction. Let's also sum the forces in the y direction. I'm going to go to the next page and paste that original diagram on there. Make it a little smaller. So now we're basically just summing the forces in the y direction equals 0. Oh, actually I did the wrong diagram, so I'm just going to pause it and put the right one in. All right, now I've got the free body diagram. I'm sorry about that. So now I've got FAC times, and this is the y component, so 3 over 3 square roots of 2 plus FAB times 3 over 5 minus FAD that equals 0. So we know FAB, right? And we know now we can figure out FAC is that KAC, so that 20 newtons per meter times that change in length. So right now it's 3 square roots of 2 minus that 0.8485. That's meters. And then we have, so that's FAC times 3 over 3 square roots of 2. And then we have plus that FAB, which is going to be that KAB, so that 30 newtons per meter, times that change in length, which will be 2 meters, times 3 over 5, minus FAD equals 0. And so we can multiply all that out, which is what I'll pause and do now to get FAD. So now we get 48 is that first term here, plus, let's see, 30 times 2 times 3 over 5 plus 36 equals FAD. So FAD equals 84 newtons. And I'm going to do a thing really quick where I can check these. So newtons over meters, meters. So that's newtons in that one. This one's newtons. So it makes sense that it's newtons. All right, so now we know what's sort of going on, but the last thing we want to figure out the mass of the box. So I'm actually going to draw another free body diagram. So if we look at that point D, then the force going up is that force of AD, and the force going down is the weight, which equals M times G. So if we sum forces in the y direction equals to 0, we get FAD minus W equals 0. So let's pause for a second. All right, so then we get, so we know FAD from what we did before. So basically the weight is going to equal 84 newtons. And we know that equals M times G. So the mass is going to equal 84 newtons divided by G, which is 9.81 meters per second squared. And a newton is actually kilograms meters per second squared. So the meters and the second squared all cancel out, so we end up with kilograms, which is the right unit. So 84 and then 9.81 divided by, we get 8.56 kilograms.